All right, today we're talking about a visitor from deep space, and I mean deep space. Its name is 3I/Atlas, and it came from another star system entirely. But here's the thing, this isn't just some run-of-the-mill cosmic traveler. No, this one's a complete rule breaker. It's defying pretty much everything we thought we knew about how comets are supposed to act.
So, what happens when a visitor from another star system shows up and just refuses to follow the rules? This thing is challenging the very laws of astronomy as we know them. It's not just a little weird, it's doing things that should be, well, impossible. So the big question is, how on earth do you even begin to explain something like this?
To figure it out, we're basically going to become cosmic detectives. We've got three major puzzles to solve. There's this impossible glow it has, a weird case of missing carbon, and a tail that's pointing the completely wrong way. Each one of these mysteries is a clue, and if we put them all together, we can start to piece together the incredible story of this comet's journey.
Okay, let's dive into the first mystery, this impossible green glow. So here's a fundamental rule of comets. As they fly away from the sun, they get colder, and so they get dimmer. Simple, right? Well, this one is doing the exact opposite. It's getting brighter as it moves away from the sun. It's a puzzle that just seems to defy basic physics.
Look, it's really straightforward. For any normal comet, you move away from the sun, you get less energy, and your glow should fade out. Period. But as you can see here, 3I/Atlas is a total anomaly. It's getting less and less energy, but its glow is actually getting stronger. I mean, think about that. It's like a campfire that starts roaring after you've stopped adding wood. It just makes no sense.
So, how is this even possible? What could explain something so bizarre? Well, the leading theory is this really cool phenomenon called thermal lag. And honestly, this idea might just be the key to unlocking this whole first mystery.
Okay, to get your head around this, think about cooking a really thick steak. You sear it on a super hot grill, right? The outside gets cooked immediately. But even after you take it off the heat and let it rest, the inside is still cooking. That heat from the surface is slowly working its way to the center. That's thermal lag in a nutshell. And that's what scientists think is happening here. When 3I/Atlas zoomed past the sun, its surface got flash heated, like a blast furnace. Now, all this time later, that intense heat is finally reaching the deep frozen core, causing all that ice to vaporize and erupt in this brilliant green glow.
All right, so we've solved the glow, right? Case closed? Not so fast. Because solving one mystery just opened up another, even weirder one. See, that specific green color, that's the unmistakable chemical signature of carbon. But when astronomers first looked at this thing, they found almost no carbon at all. So how can it be glowing with the color of carbon if the carbon isn't there? This was a real head-scratcher. As one of the scientific papers put it, finding a comet this low in carbon is kind of like finding ocean water with no salt. I mean, it's a fundamental contradiction. The very ingredient needed for the green glow seemed to be missing. It left scientists completely baffled.
The answer to this vanishing carbon trick seems to lie in the comet's incredible backstory, its long, lonely journey through interstellar space. For literally billions of years, it was being bombarded by something called cosmic ray processing.
And listen, we're not talking about a little surface tan here. These cosmic rays are high-energy particles that have been hitting this comet for eons. They can actually penetrate and change its chemistry down to a depth of 15 to 20 meters. To put that in perspective, that's like fundamentally changing the entire chemical makeup of a 5-story building. This is a deep, deep change.
So here's the theory. Think of it like a cosmic eggshell. For billions of years, all that cosmic radiation built up this thick, chemically altered crust on the comet. It didn't destroy the carbon, it just rearranged it into weird forms our telescopes couldn't see. But then, when it flew past our sun, that sudden, intense heat wave acted like a hammer, cracking that shell wide open. And what was underneath? Fresh, untouched, carbon-rich material from the interior. So the carbon wasn't missing at all, it was just hiding.
Okay, that brings us to our third and honestly most visually bizarre mystery, the anti-tail. We have pictures of this comet with a tail that appears to be pointing towards the sun. I mean, just think about that for a second. That's not just weird, it seems to fly in the face of everything we know.
Because the number one rule of comets is simple. The solar wind from the sun pushes its tail away, always. Like a windsock in a breeze, the tail always points away from the source of the wind. Yet here was 3I/Atlas, for months on end, with this prominent tail that was pointing straight back at the sun. How?
Well, this observation kicked off a huge debate among scientists. There were basically two camps. The first said, hey, maybe it's just an optical illusion, a trick of perspective caused by big, slow-moving dust particles. It's rare, but we've seen it before. The other camp, though, proposed something way more radical. What if, they said, that anti-tail is real? What if it's proof that this comet isn't one solid object at all, but a whole swarm of fragments? This is where it gets really interesting. A Harvard scientist, Avi Loeb, was a big believer in the fragment theory. And he didn't just guess, he did the math. He made a very specific, very bold, and most importantly, a testable prediction. He calculated exactly how far those fragments should have drifted towards the sun by a certain date in late November.
And then the moment of truth. They pointed the Hubble Space Telescope at it to check, and what did they find? The tail pointing toward the sun was almost exactly 60,000 kilometers long, a near-perfect match to his prediction. It was this stunning confirmation and just incredibly powerful evidence that, yeah, this thing is a swarm of fragments.
Okay, so let's take a step back and put all these puzzle pieces together. We have the impossible glow, the missing carbon, the sunward tail. What does all of this tell us? What's the life story, the cosmic biography of this incredible visitor? You know, it turns out that every weird thing this comet did was actually a chapter in its epic life story. That weird outer shell, that's the story of billions of years spent wandering the lonely, empty space between the stars. That delayed glow, that's the signature of its very first, incredibly violent encounter with a star, our sun. And the anti-tail, that's the final plot twist. It tells us it didn't actually survive that encounter in one piece. It's now traveling as a broken swarm. And that's why this whole cosmic detective story is so important. 3I Atlas isn't just some weird comet. It's a messenger. It is literally a physical piece of the vast empty space between the stars, delivered right to our cosmic doorstep. And it's carrying the secrets of its incredible journey with it.
Ultimately, the story of 3I/Atlas is amazing proof that the universe is just packed with these incredible objects, each with its own epic history that we're only just beginning to figure out. And it really makes you wonder, doesn't it? What other secrets, what other cosmic rule breakers are wandering out there between the stars, just waiting for us to find them?